Hello everyone, welcome to IEEE Expert. Today we are going to see one of the interesting project which is named as flood prediction using machine learning. This is the very innovative project which could save millions of lives in India. Flood prediction not only a technology. Flood prediction belongs to people. It's more about hope, communities and future. That's what we are going to do. We are not only building a technology using machine learning. We are building hope for the peoples. So, with the help of hopes, we can save millions of lives in future. So that this project will be more important for the current society stand. Last year itself, we lost 512 people lives due to the flood. So you can see the importance of this project. Okay, flood prediction is not an easy task. You should analyze various amount of data. For example, weather report, river levels, satellite images, historical flood data. These are the data you should consider. But these data are huge in real time. But thanks to the power of machine learning, with the help of this machine learning technique, we can analyze these data very easily. How we have to analyze these data? So this project works on machine learning. In this project, we are using convolutional neural network as a trained algorithm. You have to give various data to train. For example, you have to give historical data as a historical rainfall data, current rainfall data, then dam levels as well as satellite images. These are the data you have to consider to give as an input while training. These data will called as a dataset. What CNN will do means it will take relative features from the dataset which you are giving. It will take, while the flood happening in the existing system, it will take what type of features, what type of serious correlation will happen. For example, if the dam level was in this level, if the rain will happen in this level, maybe the flood will happen. This correlation factor that will consider. The CNN will consider this correlation factor, this relation factor from the dataset which you have given. Then what it will do means, it will match the correlation factor with the current real time. Now what's the dam level? Now what is the satellite imaginary value? Now what is the rainfall value? It will compare this current level values with the previous dataset value. Then it will find the relative propagation. How much propagation of flood will happen? How much propagation of landslide will happen? That's what this CNN will do. The main accuracy of main advantage of CNN here was it having 97% accuracy, which is huge in real time. Okay, you can predict the flood exactly when the flood will happen, where the flood will happen, how much amount of flood will happen. This thing you will predict very easily. The landslide also you can consider from the flood level. So this is the project. Please connect with this video. We will explain complete demo of the project with presentation, with coding and everything. Thank you. Let me explain the project base paper as well as presentation. This is our project base paper. This is IEEE based base paper. Okay. The title is Spatial Temporal Flood Hazard Mapping Using Integration of Telemetry Data and Prediction Model. This is the project base paper we have considered for this project. In the project base paper, they have taken LSTM algorithm. They have taken LSTM, long short-term memory. This is the algorithm they have used to train as well as testing this project. The main drawback of this project was they have achieved very low accuracy. As you can see, they have achieved 74% accuracy. The main drawback was this one only. 74% accuracy only they have achieved for this project. The architecture of the existing system shown here. They have considered water level as well as hourly water level as well as daily water level. These data are trained under temporal prediction model that is called LSTM. Based on that only they have estimated the flood region. This is completely existing system, very low in accuracy. To overcome this drawback only, we are going for our proposed system. So this is our proposed system PPT. As you can see, the title was Flood and Landslide Prediction using Machine Learning. We have created flood as well as landslide prediction. Both the model we have created for this project. The abstract we have mentioned that natural disasters such as landslide as well as flood are pose significant challenges in human regions. Okay, this study present innovative machine learning approach to predict this landslide as well as flood insecurity in susceptible areas. This is the abstract for our project. In this project, we are using historical weather patterns, dam levels, land usage, what is the weather data, socio-economic indicators to predict the how much loss will happen, okay, how much wealth loss will happen. We are using this 5 input in our data set to train, okay. In introduction, we are given that how frequently, how severely this natural disaster raised to significant concern, okay. So we have to make sure proposed algorithm able to predict this flood as well as landslide very efficiently. That is the major motto of this project, okay. Why? Because India contains India having more number of human lives as well as India having more number of forests when compared to other regions. So the flood as well as landfall prediction or landslide prediction is very important for India, okay. The role of machine learning here was the predictive approach. In this project, we are using predictive approach. For prediction means you have to apply huge accuracy, higher number of accuracy. For that purpose only we are using machine learning here, okay. It don't use any data mining and all. It uses pure machine learning approach. The main focus of this project was 2 things: flood prediction as well as landslide prediction. These are the main 2 focus of this project. The exiting system uses 3 models. Hydrological models. Hydrological models means the base paper contains water level. They are solely used to water level to predict the flood. But we are using some advanced consideration. Okay. The hydrological model, remote sensing. Some persons using satellite maps to predict the water flow at all. Okay. And rainfall prediction. These are the exiting methodology used in our project. But the main drawback was data scarcity. Data scarcity means you can't get exact data for all the region in existing system, but we are using proposed API here. The proposed API capable of getting all the data for all the regions. Okay, we are using API here. Let me discuss everything on the project demo section. Computational complexity. The LSTM prone to complexity. Okay, it can't handle all the data. The main drawback of the LSTM was computational complexity. Then model interpretability. Model interpretability means the deep learning things was difficult to interpret, making challenge to understand how the predictions are made. Okay, you can't understand the data clearly. That is the main drawback of the existing system. These drawbacks are overcome by our proposed system. In our proposed system, we are going to predict flood as well as landslide. Both the things we have to predict. Okay, this system integrate satellite imagery, rainfall pattern, then topographic patterns as well as soil moisture level, river flow levels. These factors are considered to predict the flood as well as landfall direction. So that this accuracy of the project was huge when compared to the existing system. The main algorithm used in this project was convolutional neural network. This only achieved the 97% of accuracy. Okay, as well as the proposed convolutional neural network model can be continuously trained as well as upgraded, okay, over the time to improve the accuracy. So this system also includes the real-time monitoring as well as proposed prediction model. Both the things included in this project. This is the overall architecture of this project. In the architecture, as I mentioned earlier, I am using historical data. Sensor data means what's the current temperature, what's the current rainfall rate as well as current water level of the particular dams. These are the sensor data. Then weather forecast. Weather forecast means predictable forecast. What is the maybe rain will come tomorrow or not? What's the expected range of temperature for tomorrow? These are the data called as weather forecast. Then hydrological data means, as I mentioned here, what's the dam level, how much amount of water that dam can survive. These are the data called as hydrological data. These data are collected and these data are pre-processed. Then we made final data set. From the data set, we made feature engineering. Selected features can be pruned from the data set. That features can be trained under the particular CNN model. Okay, that CNN will train particular feature. It store on the particular model. Okay, then we are using Flask model to validate this result. We are building particular website. In the website, you can give the input. Particular area, what are the area you have to consider. You can give the area name. Then what our project will do means it will fetch the real-time data for the particular place, These real-time data are always compared to the already pre-trained model. Based on the pre-trained model probability, it will give whether you are having flood alert or not. Okay, these things are accessed by the user interface. As I mentioned earlier, by using Flask, we made a beautiful website for this project. These are the 4 models involved in the project: data collection model, pre-processing model, then model selection, then predicting model. These are the 4 steps involved in this project. Okay, models. This is the sequence diagrams of the project: class diagram, activity diagram, use case diagram, all the diagrams given for this project. If you're purchasing means you can access all the things for free. Okay, you can see the result. Okay, the proposed model having accuracy of 97%. As I mentioned earlier, existing model having accuracy of 71%. The precision rate of proposed system was 97, as well as existing system having precision rate of 70 only. The proposed system having FL score of 99, existing system having FL score of 81. So you can see the accuracy of our project, which is improved by huge margin. This is the hardware requirement of the project. You need minimum i3 processor to run this project. Okay, in this project can be run on Windows as well as Mac OS. We need Python to run this project. In conclusion, we have given that this is the interesting project. With the help of CNN, we have improved the prediction model of flood as well as landslide. It poses significant advancement when compared to the base paper. We are accessing vast amount of data set to make the accuracy, as well as the data set contains historical weather pattern, topography, as well as soil condition. We are using machine learning model that's called CNN to apply the predictive forces. Reference for this project. Okay. Please connect with this video for demo sessions. Let's move on to the project demo. So this is the project code folder. You can find the complete coding here. This is already pre-trained model. This is our Python code which you are using. This is the training code which are used to predict the project. Then this is the template folder. In the template folder we have used front-end HTML pages. Okay. To run this project, you have to copy the project code location, then open Anaconda Navigator. Just click Python terminal. Once you open the Python terminal means use cd space paste the project location, then enter. To run the main project, you have to type python space app.py. This is the command used to run the main project. So once you type the python space app.py means it start run the project. So it's executed now. So this is your localhost address. Just copy the localhost address, paste it on the browser. So this is our project homepage. This website running from our terminal. Okay, this terminal only generated this website with the help of these codes. Okay, so you can find the complete project on the localhost. To start this project, this is our homepage. We named our project as a flood guard powered by AA. This is our project code folder. This is our project homepage. We have created some homepage about our project, about us, everything you have mentioned. Then what are the services we are providing means plot, heat maps, satellite images, predict flood. These are the services included in this project. So then why this project important means this project will help on the first aid, rescue operation. Also this project we can estimate to predict how much food supply person will demand while flood happening. So this is our contact us form. Then some frequently asked question also we have displayed. This website completely running with the help of Python. Okay, this website completely running with the help of Python. The first step which you are going was plots. In the plots you can see the complete flood areas. Okay, flood prediction. What are the places will be flood prone in India? You can see the complete results. Okay, you can see the complete results. In the red colored things referred to frequent flood occurring places. Okay, the number belongs to latitude and longitude position. This graph automatically generated with the help of our prediction. You can zoom also. If you are zooming here means you can get the clear idea. For example, Mumbai prone to flood. Then also you can get Chennai. Chennai also prone to flood. Then Kochi. Then Thiruvananthapuram. These are the places prone to flood. These are the places, okay. Then the second graph belongs to how much flood will happen in the each and every place, okay. How much flood will happen on the each place. This graph, completely dynamic graph, will be generated based on our prediction process, okay. You can see the flood intensity. This is flood intensity graph. You can see these are the places flood may happen in the huge data, okay. This is the flood intensity graph, okay. And this is the flood intensity graph. Then third graph will be how much rain will happen on the each and every places. How much rain will happen on the each and every place. You can see the rain plot here, okay. These also will be generated based on our plot, okay, prediction plot. Then go for the heat maps. Heat maps directly related to our satellite. So this is the heat map. Heat map belongs to how much loss will happen in terms of US dollars. So if flood happened means how much loss will happen in terms of US dollars. This also very much important. Why? Because if the flood happening in forest places means there is no huge loss for few months. But if the flood happening on the metro city means the loss ratio will be higher. The heat map will help us to find out how much loss, how much money loss will happen in terms of flood as well as rainfall. Okay, you can see if the flood happening on the New Delhi means this is the New Delhi surrounding. If the flood happening on the New Delhi surrounding means the loss ratio will be huge. Also the flood will happening on the Mumbai side means the loss will be huge. Why? Because these areas are surrounded by various number of peoples, okay, huge population. That's why it will make huge loss, okay. That's also important. Also in heat map you can get Chennai prone to less loss when compared to Delhi. Why? Because Chennai population count is different as well as Chennai architecture count is Chennai architecture style is different, okay, as well as Chennai sewage policy also different. So while compared to Chennai, Delhi will meet huge loss for the same amount of rain, okay. Then participation also refer to the population ratio and loss ratio. Here also you can find out Delhi, Mumbai, then this place West Bengal. These places are prone to flood as well as huge loss if some rain will happening means, okay. So this also heat map. Then directly I can go for the satellite. These graphs are completely generated by our prediction process. These graphs are completely dynamic, okay. It will change automatically. So for example, if you are going for Delhi in June month means you can see the rain data here. In rain data, these are the data, rainfall data for Delhi. If the same thing I am turning into July means, you all know in July 3 or 4% died on Delhi. You can see the complete graph. Compared to June, you got huge rainfall in Delhi surrounding. Also you can change the city here. For example, I taken Mumbai in May. I have taken. You can see the result. May, Mumbai got low rainfall. So I can turn into July for Mumbai. So compared to May, in July month, Mumbai got huge rainfall. This is the cloud ratio from where clouds are gathered near to Mumbai. Okay, I can change into Chennai also. These are the metro city. I can change. So Chennai got less amount of rainfall compared to other metro city. This is the important page in our project, prediction page. In prediction page, you can type any city in the world. What this project will do means, it will fetch the latitude and longitude position of the particular city. It will get the weather data from this API, Visual Crossing API. This project, real-time project, you can check this project any date, anything. Okay, it will work perfectly. This is the API we have used to collect the data, real-time data. For example, I am using Chennai here means it will give the Chennai results. Okay, this is the Chennai result. Okay, Chennai temperature, rainy days, what's the wind speed and all. You can get forecast for 15 days, 40 days, everything you can get yesterday, today. So what our project will do means, in our project, we will get complete graphs from this website. using this graph, it will perform the machine learning operation. It will perform the machine learning operation for the current data, live data. It will collect live data from this website. Based on that live data, it will predict whether the rainfall or the landslide may happen. It will predict that. I'm just typing Chennai here. So before that, you can check the command box. If I'm typing Chennai here means what my project will do means it will get the latitude longitude portion of Chennai. You can see the things latitude longitude portion of Chennai. Directly this latitude longitude connect with this website. It will get the real-time data. Based on the real-time data, it will perform the prediction operation. See the thing. So Chennai belongs to safe category. According to our ML model, we did not detect any sign of potential flood. So in Chennai, you don't find any flood data. Okay. So you can check the results also. In Chennai, the average temperature will be 85 Fahrenheit. Maximum temperature will be 93 Fahrenheit. What's the wind speed in Chennai we are getting? 30. This is today results. Okay. Your wind speed 13.78 mph, as well as what's the cloud coverage? 88% of cloud coverage is there. Okay, what's the humidity ratio? 72. These results belong to Chennai. Chennai did not find any flood things. Okay, any potential flood related things. What I'm doing means check the today date. I'm just going for the Delhi. You can type Delhi here. So for Delhi also you can get the latitude longitude. So after getting the latitude longitude, it will collect all the real-time data with the help of API. It will collect all the real-time data, satellite maps and all. Then it will predict how much maybe flood happening or not. You can get the result. For Delhi, unsafe. According to our ML model, this area has potential risk of flooding within next 15 days. Potential risk of landslide also may happen. Please take emergency measures. This result for Delhi. Okay. Depends upon the city. The results may change. Belongs to our machine learning model. You can get temperature results for Delhi, maximum temperature, minimum temperature, as well as wind speed, cloud coverage, then how much participants means the people ratio, then how much humidity happening. Okay, sorry, I mispronounced that. Precipitation, how much precipitation will happen. All the ratios will get real time. Okay, with the help of this API. After getting this API, after getting this data, it will perform the machine learning operation. Then only it will give the result. What I'm going to do means, I'm going to do for the Mumbai. Mumbai I'm giving results. So if I'm typing Mumbai means, so after typing Mumbai, you can see the results. Go for the things. So this is our Mumbai, latitude, longitude of Mumbai. It will get all the data from the API. Then it will perform the machine learning operation. Mumbai flood prediction safe. Okay. According to our ML model, we did not find any sign of potential flood. What's the Mumbai temperature, maximum temperature, wind speed, precipitation value, everything you can see here. Then what I'm going to use means, I'm going to enter Hyderabad also here. So I'm going to use Hyderabad. I'm going to type Hyderabad. So you can get the result for Hyderabad also in our API. So we typed Hyderabad. This is the geological position of Hyderabad. Then you can see the result. So safe. Usually in Hyderabad flood may not happen. So we got the results also. So we did not find out any potential flood. Okay. This is Hyderabad result. This project not only belongs to Indian city or Indian state, you can get results for any city in the world. So I am using London here. So London, New York, you can type any city, it will work. Okay. I'm just typing London. So after typing London, so let me check it got London or not. Okay. You can see response. London, latitude, longitude. So it got result for London also. Safe. According to our ML model, we did not find any potential flood. So if we have checked 5 cities, Delhi only having potential risk of flood for today date. For any date, this project will work perfectly. Okay. So London maximum temperature, average temperature, wind speed, cloud coverage, then precipitation value, humidity value. So these are the results for London. Okay, this is completely end-to-end project with the help of machine learning. This is very interesting project as well as very important project for current days. Okay, this will help us to save millions of lives if we apply it perfectly. To know the accuracy of this project, just go to the accuracy tab. You can get the complete accuracy of the project. So this is accuracy score of our project. You can see the accuracy around 97%. So this is our accuracy. We got around 97% accuracy for our proposed system. Also, what are the features we are considered for training means? So drainage value, dam quality, river management, political factors, then population score. These are the important features we have considered to execute training as well as testing of the project. Based on these features only, it will detect whether the flood may happen or not. We have considered drainage also here. See the things. This is confusion matrix our project. Then overall architecture of our project. So this is overall architecture. Okay. To get this project, please visit IEEE Expert. We have displayed various projects for best price. Okay. You can get all the projects from this website. Okay. We have displayed various projects on machine learning as well as blockchain. Thank you.